Hi everybody, it's Ms. Casbero again. This is the first part of the notes. This is on Behavior and Extrema. So the first thing we need to understand is what those words mean. When you're talking about the end behavior functions, you're talking about if you've got a graph going like this, what is it doing on the ends? That's at the end of it. And that's at the end of it. So what is it doing on the end? Is it pointing up? Is it pointing down? The other thing was extrema. That was what we had in behavior and extrema. Extrema are the extreme values. Those are the low points and the high points. Okay? So that's what we mean when we're talking about end behavior. What is it doing on the end? And the extrema, which are our low points and our high points. We will get around in this, determine whether the function's increasing or decreasing on the next slide. Okay. Critical points are those points on a graph at which a line drawn tangent to the curve is horizontal or vertical. What it means is it's going to be a high point or a low point. Okay? Those are critical points. All right? When it's got a vertical line, that is a point of inflection. That means it's kind of a twisted point. It's not a high or low. It's one of those that's twisting from going up to now that way. It twists. Okay, we've got one like that too. There's a twisting point. Okay, a critical point may be a maximum, a minimum, or a point of inflection. When the graph is increasing up to it and then decreasing, okay, it's a maximum. Decreasing and then increasing is a minimum. Okay, at one point this is increasing and the next it's decreasing. It changes its curvature. Okay, so it's kind of the twisted points, what I like to think of it. These are showing some extrema. The graph of a function can also provide a visual clue when it's got a maximum or a minimum. The Desmos.com is going to be really helpful in this. Most of your assignments deal with that so that you can put them on a graph and actually see. Now, when you've got a low point here, and there's no point that goes lower in this, that's called an absolute minimum. That's as low as it goes. Okay? If it got one graph like this, and that's a high point, it's an absolute maximum. Doesn't get any higher than that, and so it will always, that's it. Right here on a graph is a point that's not quite as low as it goes, but it is a low point for what's around it. That is called a relative minimum. Relative to everything around it, it's a minimum. Okay? Relative to everything around this point, it's a maximum. But it's not an absolute maximum because you can see this goes on forever. So there's never going to be a high point on this thing. But relative to everything around it, it is a maximum, and relative to everything around it, it's a minimum. This is as low as it goes, so that's absolute. And that's just what this is stressing right here. If you've got a high point for everything that's around this, that would be a relative. A low point for everything that's around it would be a relative minimum. Okay? The extrema are the y-coordinates of each maximum and minimum point. So right here, this point is about 0.75 and 1.9. That's what this point looks like. How you would say that is at 0.75 there is a relative maximum of 1.9. That is the relative maximum. So that's what they're saying when they're telling me they are functions. They are the y coordinates. There is a relative maximum of 1.9. Okay? So they are the y coordinates. All right, locate the extrema for the graph and name and classify. So you come down here and you can actually see it. It has a relative minimum at -3, -1. So at -3, it's a relative minimum of -1. A relative maximum of 5 at 1. And a relative minimum of -4 at 4. Okay? There is going to be no absolute, there's going to be no absolute maximum because these go on forever and ever. Okay? But there is an absolute maximum. This right here was not only a relative minimum, it is also an absolute minimum because it goes no farther than that. Okay? All right, so this next one here. The function f of x equals 2x to the 5th plus, minus 5x to the 4th minus 10x cubed has critical points at x equals -1, x equals 0, and x equals 3. Excuse me. Determine whether each of these critical points is the location of a maximum, a minimum, or a point of inflection. Well, right here they're finding out what happens on each side. So they do a 0.1, -1, -0.1, -1.1, -0.9. So they find out are each of these lower than that? If they're lower as coming out, then it's a maximum. Then they find out if these 2 points on either side are higher, then it's a minimum. If you've got one higher and one lower, that's a point of inflection. But what we have done before is we go on to Desmos.com and get the calculator. And then we just see what we've got. All right, so we had 2x to the 5th, 2x to the 5th minus 5x to the 4th minus 10x cubed. I'm writing that down really fast so that when I go to Desmos, I'm going to be able to write it down. Okay, 2x, and down here you pull that up, and I'm not going to be able to see all of it with this. 2x to the 5th, I just changed that squared from the 5th, to the 5th from the square, minus 5x, oh there it is, a to the b, 5x to the 4th, right here, minus 10x cubed. Okay. And now I can see exactly what my graph is doing. Okay? So you've got right here a high point, a point of inflection, and then a low point down here at the bottom that I can't get to with what I can use here. But you can go right back over here to this. And get this where you need it to be. Okay? You can tell them at school the bells keep going off. Sorry about that. Okay, this is about 11 minutes right now, so I'm going to wrap this up and then we'll finish it on the next one. So they told us that -1, 0, and 3, and you've got the Desmos calculator. And at -1, we knew it was a maximum. We saw it on the calculator. Okay. We knew that 0, it changed positions on us. Okay. And then we could see at 3, we're going to have the low point. So, using the calculator, we can get our 3 points without having to do all the algebraic stuff that they're telling us about. Okay? So just, like I put in red down here, see what you need to classify the points using Desmos.com. All right, I'll see you on the next video.